Alright, now we're going to talk about digital electronics. In ACSL, digital electronics are visual representation of circuits in which certain switches are turned on and off, and this can lead to the output being on or off. As you can probably tell, digital electronics is also another way to think of Boolean algebra expressions, and all of the digital electronics and circuit operations can be translated into Boolean algebra expressions. For example, the circuit that I just drew is an example of an AND sign in which A and B are being combined to yield some outcome X. Depending on whether A and or B is turned on or off, X will either be on or off. Another way we could write this is A and B equals X. So, if we go through the different possibilities for A and B, we can see how this would impact X. So A can either be on or off, and B can either be on or off. Now, if both A and B are off, X is off. If A is off and B is on, X is off. If A is on and B is off, X is still off. And finally, only when both A and B are on is X on. Here we can see which pairs turn X off or on. The only pair that would result in X being on is this one down here. Or we can write that as 1, 1. All of the digital electronics circuit diagrams can be rewritten into Boolean algebra expressions so we can solve for what will change the output. Again, this simple circuit above was the representation of the AND operation. Here are all of the digital electronics operations that you will see on ACSL. As you can see, we've looked at all of these with Boolean algebra, and these are just expressed through circuits. You can combine multiple operations to make a more complex circuit, or you can just have a very simple circuit as you see here. The tables all the way to the right will show you how X changes as A and or B is turned off or on. For an example of an ACSL problem using digital electronics, see the next video.